YouTube. So this is another video with my project, the Constantine PowerWall, and I still working over to my multi-charge and discharge tester battery. If you watch my other video, you see I have a modular one, a 32 battery is the first model for discharging 32 battery, but this charger was made with a constant load. Is the simplest way to make it, but can be better if you make and easy to calculate the real capacity of the battery if you make a constant current discharge. So a lot of people ask me why I don't do that to make a constant current discharge for this 3.7 battery. So let's discuss a little bit about the theory of that, the comparison between the constant load and constant current, and after that I will tell you how can you do it and how I will do it. So the law of Ohm, it's simple. The I, it's U, the rapport from the voltage and the resistor. We know in our case the voltage will not be constant, because when this battery is full will have 4.2 volts, and when is empty have 2.5 volts. It is not good to discharge less than 2.5 volts because the battery will be damaged, so you don't want to do that. So if you take these two values and make this rapport, in our case in I will be 4.2 when it's full, and in my case I use a resistor of 10 ohms, so it 4.2 over 10, so it will be about 420 milliamps hour when it's full charge. When it's empty, the battery will have about 2.5 volts, and over 10 I'll have 250 milliamps on this charge. So when you want to test the battery, the real capacity of the battery, you'll need to make a lot of math to calculate this, because the I will drop from 400 to 420 milliamps hour to 250. So let's make a little graph here. So this is the graph, this is the time, this is the I. So we'll go from here. When you start, it will be 420, and we'll drop like that to a point where it's only 250. To calculate the real capacity, you need to take a lot of samples from here and to add it. So you'll make like that. The capacity will be an sum of all these little points here, the capacity, the current. This is read it in one time. So if you have a lot of samples, this is the time here. So if you have a lot of samples here, take it, your capacity will be really good, but you'll need a lot of samples to calculate that. But also you need to know this little battery have a different capacity if you discharge it constant with 42 or 1 amps. I test that with my iMax B6, and it's a difference. It's about 100 milliamps. So in my case, let me show you. This is one of my test battery here. So this one is a damaged one. So if I discharge constant with 1 amps, I have a capacity of 528 milliamps hour. If I discharge it with 0.5 amps on hour, my capacity will be about 684 milliamps hour. So if I discharge with less current, the capacity will be bigger. And also, if I discharge like that with my constant load, because the capacity will drop less than 5, so this is for 0.5, this is 1 amps. Because my capacity is less than 0.5 and drops down, the current I discharge is less than 0.5 amps and drops down, my capacity, I calculate it's about it's about 906 milliamps hour. So this is my constant load measure. So if you do that, if you can see that, it's a big difference from 906 and 528. So I think the better and the more real, it's something between this value. So maybe it's the real capacity is about 684 at 0.5 amps hour discharge. So this is the problem. To do that, to do a constant current discharge, the schematics a little more complicated, but the math is easier, because if you have a constant discharge like this, let's suppose you discharge with 0.5 amps over a period of time, the current will be the same. Let's take it 2 hours. You'll know here you have a capacity of about 1 amps per hour, because you make the math 2 hours or 0.5 will do that. So 2 or 0.5 will be 1 amps hour. So it will be easier to read it. You don't need to take a lot of samples. You only need to know when you start to discharge and when your discharge ended. Depend of the project. In real application, I don't know if any of this battery will discharge with a constant current, because usually you will need more or less power in the moment. So maybe you'll discharge like that, maybe not. But let's suppose you will need same power from this battery, and if you know what power you want to discharge it, so if you want to discharge with only 0.5 amps, you want to know the real capacity on 0.5 amps, not with a constant load, the variable capacity. So you want to know, if you discharge with 0.5, how much time I have with this battery. So let's do it. Let's make a constant discharge. Let's talk about the schematics to do this.